Where did our sun come from? Are there stars older than the sun? Are new stars still being formed? We will take a look at these questions and more in this part of the Our Universe unit. All of the elements found in our sun, and on the Earth, can be found in these stellar nurseries. Dense molecular clouds are made up of many types of substances, but hydrogen and helium are by far the most abundant of these. Discoveries of complex organic compounds including amino acids, are significant in terms of the possibility of life existing elsewhere in the universe. For stars to form from the materials found in dense molecular clouds, something has to happen that triggers collapse of pockets of this material. One likely suspect for triggering the collapse are the shockwaves produced when a star becomes a supernova somewhere nearby. The nebular hypothesis is a model used to explain how new stars form. Once the collapse is triggered, the gravitational attraction of denser regions for surrounding material causes gas to collapse inward. Rotation of the cloud flattens it into a disk. The material in the center continues to increases in density as more material falls inward. For our solar system, this created the protosun. Rings of material surrounding the protosun formed the planets. Denser pockets of material in the rings gathered material from the ring as they orbited the sun. They grew by this process of accretion into planetesimals, then protoplanets, and ultimately the planets we see in our solar system today. The Orion Nebula is a well-known star-forming region in the constellation of Orion. It is the fuzzy object in the handle of Orion's sword. New stars are forming there even now. This is a close-up view of the dusty cocoon known as a proplyid in the Orion Nebula. These dusty cocoons surround newly forming stars. In this one image you can see stars in the different stages of their life cycle. This rather complex graphic shows sources of gas and dust for the formation of new stars. Some comes from the constant outflow of material carried on stellar winds, like our sun's solar wind. Older stars eject huge amounts of gas and dust as they go from main sequence stars to red giants, and finally white dwarfs. Novas and supernovas also send out lots of star stuff. To study the formation and evolution of stars, astronomers use many different wavelengths of electromagnetic radiation, not just visible light. The two images of a portion of the Orion Nebula shown here were taken with two types of light, visible light on the left and infrared light on the right. Using infrared light, astronomers are able to see inside the gas and dust and see newly forming stars. Infrared light is absorbed by our atmosphere, so to use it to study star formation, astronomers need to get above most of the water vapor in our atmosphere. One way to do this is to put your telescope in space. The Spitzer Space Telescope was one of NASA's great observatories and used infrared light to image the cosmos. Having run out of coolant and fuel for aiming at different parts of the sky, it was decommissioned in January of 2020. The infrared spectrum extends from wavelengths of about 1 micron to over 100 microns. Spitzer was capable of imaging over a broad portion of the infrared spectrum. Other sources of infrared images of stars and galaxies included WISE. WISE was a survey mission that used a smaller portion of the IR spectrum but covered wide swaths of the entire sky. The James Webb Space Telescope is promoted as a successor to the Hubble Space Telescope, and will be launched in 2021. SOFIA is a novel approach to infrared astronomy, using a modified 747 aircraft to carry an infrared telescope into the stratosphere. SOFIA, or the Stratospheric Observatory for Infrared Astronomy, flew its first science mission in 2010. Not long after, NASA initiated its Airborne Astronomy Ambassador program. I was one of the 2 teachers who were honored with the first educator's flight. We flew a route from California to Minnesota and back again, staying airborne all night as the astronomers collected data on their target stars and nebulae. One of the targets the night I flew on SOFIA was the North American Nebula. You can definitely see a lot more structure in the composite infrared images. I was one of a group of teachers that led a team of students form our school on a collaborative project to look at star formation, using the Spitzer Space Telescope. NASA gave our students time on the telescope. Students were able to select a target and have the telescope aimed there, and take images of their target. Our students chose to look at star formation in small dark nebulae known as Lind's Dark Nebulae, after the astronomer Beverly Linds, who catalogued a huge number of these objects. Students used archival data, images from past missions, to pick a nebula that had not been studied much, and showed thick amounts of gas and dust based on its optical properties. The one they decided on was LDN 981. The image on the upper left is a composite of data taken at 3 different wavelengths by our students. Objects with an excess of infrared light show up red in this image. They may be new stars forming within the nebula. WISE, a later mission, shows the same area at a higher resolution. Students presented their results at a meeting of the American Astronomical Society in Long Beach, California. Here is the team from Chippewa Hills High School at the post-session at the conference. This is the abstract from their research paper. Our school's part of the team went on to enter their work in our Intermediate School District's International Science and Engineering Fair Regional. They won the Regional Fair for Team Project, and went on to present their study on Lind's Dark Nebulae at the International Science and Engineering Fair in Carson City, Nevada. The James Webb Space Telescope is a planned successor to the Hubble Space Telescope. It is a novel concept in telescopes, and will be launched in a folded form that has to successfully unfold after launch in order to operate properly. All of this is automated, and was a very complex engineering problem. The telescope's mirror has a much larger diameter than Hubble's, and is made up of a series of hexagonal segments. After many delays, construction of the telescope is complete. It is being prepped for launch. The telescope will be launched on March 30, 2021. Once it has been successfully deployed, the James Webb Telescope will allow astronomers to investigate star and planet formation better than ever before. Planetary atmospheres can be looked at more closely for biomarkers, signs of life. It will be an exciting time for astronomers.